Okay, here we want to take a look at linear functions and slope in this segment. A linear function uses our f of x notation, and it says f of x is equal to mx plus b, and the condition is we don't want our m to be 0. That'd be a pretty boring function. It is a function, it's a constant function, but usually we want to have a coefficient here that's not 0. We want to have an x term, and because it's a linear function, you can guess that when we graph it, it's going to be a line. Now, let's talk a little bit about special cases of horizontal and vertical lines. Are these functions? Are they not functions? If so, what do they look like? A horizontal line, okay, so that means like this green line here. I've got a couple ordered pairs already labeled, and you'll notice that every single one of these ordered pairs is going to have a y coordinate of a 1. So we're going to have to fix the y, make y equal to 1. That's going to be the equation for that specific line. In general, we would say y is equal to b. All right, well, what about a vertical line? I've got a blue one here. I've got some ordered pairs labeled, and what do you notice about each of those? Yeah, that's right. All the x's have to be the same value, and in this case specifically, x has to equal 2. So in order to get a vertical line, we're going to have to fix our x-coordinate, and in general, we would say x equals a. Now, if you remember when we studied about visual tests for functions, something has to pass the vertical line test. This green line passes the vertical line test. No matter where you hit it with a vertical line, it's only going to cross once. So this horizontal line is a function. And this would be our f of x equals b, that constant function. The vertical line, on the other hand, it causes all kinds of problems because it's not going to pass that vertical line test at all. And it is not a function. It's a simple, nice equation, but it's not a function. One other thing to pay attention to here, the horizontal line has an equation of y equals, the vertical an x equal equation. Those are exactly the opposite to the way the axes work. Some people get that confused. Remember, the line equations are opposite to the axes. All right, let's take a look at that thing called slope. I'm sure you're familiar with this. Slope, generally use an m for a line, is in vernacular going to be called the rise over the run. And what we mean by rise is the change in my y's, the up and down change over the change in my x's, the run, the horizontal change. Okay, so rise and y's go together. Kind of rhymes, that makes it easier. If you want a mathematical formula, if you have two generic points, x1, y1 and x2, y2, to get the change, you would subtract the y2 minus y1. To get the change in x, the x2 minus x1. All right, and that's illustrated here in that picture. Let's look at a specific case of a function. If I've got this function, f of x equals negative 2/3 x plus 1, can I graph it and determine its slope? Well, first of all, just looking at this, we know it's going to be a line. How do we know? Because it's in that form, something times x plus or minus a number. That's always going to be a line. Okay, so one way that we can graph a line is by making a table, right? Now, if you have a fraction coefficient in front of your x, the smart thing to do is pick multiples of that denominator as your x's, because then you don't have to graph fractions. So over here in my table, I've got negative 3, 0, 3, and 6. Now, you can either plug them in and do them by hand, or watch this, your calculator doesn't care about fractions at all. Parentheses, negative 2/3. Okay, and we're going to multiply that by negative 3. Don't forget your signs. And we're going to add 1. I can do it all in one step, hit enter, and there you see the answer of 3. So if you don't like doing these by hand or in your head, then use your calculator to get the answer. Okay, it's not going to be that tricky. All right, so then I've got my pairs here. I've got my negative 3 and 3, my 0, 1, my 3, negative 1, etc. So negative 3, go back 3, up 3, there's that point. And then 0, 1, so just right up here. 3 over 3 and down to negative 1, and then over 6 and down to negative 3. And we join those and we've got ourselves a line. Now remember, the slope is measuring the rise over the run. As you move, this is important, as you move from left to right, you always have to go from a left point to a right point or you're going to get your signs mixed up. Okay, so if I pick this y-intercept point here, and I want to figure out how to get over to this point, I'd have to go down 2, so I represent that with a rise of minus 2, and then my run, I'd have to go horizontally 3 units, so my slope is negative 2/3. Shouldn't surprise you too much looking at that equation for that function, right? Let's talk in general. This was a negative slope and the line went down, and that's generally going to be the case. difference is which ones are steeper. Well, the ones that have a bigger negative number. So -1 slope, okay, yeah, that's kind of, it's like a 45-degree angle through there. -2, that's going to be steeper. -3, that's going to be even steeper yet. On the other hand, if our slope is positive, we would have had lines that go up. Same kind of idea. The bigger the number, the more steep the line. Now, what about those special cases? Well, the horizontal and vertical lines, we can talk about slope here as well. Remember that slope is measuring the rise, the change in my y's over the change in my axis. So we've got two generic points labeled here, and if it's going to be on a horizontal line, that means my y's have to be the same value. So when I take the difference on top there, I'm going to get a 0. On the bottom, I'll get whatever number x2 minus x1 is. But the point is, I've got 0 being divided by something. Well, that answer is always going to be 0. There is 0 slope for a horizontal line. Right? What about the vertical lines? Well, in this case, we've again got two generic points labeled here, and we're going to measure the rise, the change in those y's, whatever that number is going to be, over the change in my axis. But in order to have that vertical line, my axes have to have been the same value. So when I subtract them, I'm going to get a 0, but this time it's in the denominator. You can't divide by 0. That's undefined. So vertical lines have undefined slope. Horizontal lines are going to have a 0 slope. There is a difference.